Hello Year 10, and today we are starting the first of the required practicals. We're going to be using a light microscope. Now this is a very simple practical and I'm sure lots of you have done it multiple times. However, for those of you who haven't or it was a long time in the past, we're going to go through it step by step and look at the sort of questions they may ask. So the LO for this practical is that you need to be able to use a light microscope to observe, draw and label biological specimens. And for the higher tier, you need to be able to calculate magnification. Okay, so you probably think way back to Year 7 where we made cheek cell slides and onion cell slides using our very simple light microscope like this one in the picture. Now again, this is supported by the Caboodle textbook, and if for any reason you aren't able to get on with my PowerPoint, which I'm not going to be totally offended by, there is a whole section in the textbook on how to do this practical. There is also a video which I have attached above that talks through it. And the page numbers are 4 to 5. So, the diagram. Now you do need to know for the foundation to be able to label the diagram of the microscope. So here it is for you. And these are all the different bits. So often nice easy question at the beginning of the paper, what are all the parts called, or label parts A, B and C. Remember that there are coarse focus and fine focus, okay. We've got the eyepiece at the top here, okay, and that's the bit that we look for. Now that has got a lens in it, and that lens is usually about times 10. And then we have our magnification, our objective lenses here, and we have 3 lenses here that are various magnifications. We have the coarse focus knob, which is the coarse focus which moves the stage up and down, and the fine focus knob which moves the stage up and down but ever so slowly, and that's to get a nice sharp image. Most of ours in school and ones in the books will talk about having a built-in light. However, if it's really a retro or a key stage 3 microscope, you won't have a light, you'll have a little mirror. Exciting, eh? And this platform here is called the stage, and these 2 brackets here are simply called stage clips, and the stage holds the slide in place so it doesn't move around, because you can, if you remember, tilt them backwards and forwards. So we need to know a little bit about the history of microscopes. However, more importantly, really importantly, we need to think about the wider role that they play in biology and microbiology and how we use them to learn about cells. Okay. So we need to think about making a slide, and we can make a slide using our cheek cells or onion cells. However, you need to set up your microscope before you do anything. So most microscopes have a built-in light source, and the first thing we do is move the stage to its lowest position. Then we place a prepared slide onto the centre of the stage and fix it into position. Then we select the objective lens over here with the smallest magnification. And then we use the coarse focus knob to raise that stage to its highest position. And we're going to look through the eyepiece at this point and gently move the stage down using the fine focus adjustment. We can use the coarse focus until they just come into view and then use the fine focus, or you can start off by just using the fine focus. Now the reason we drop the stage right down is so that we don't damage the lens by dragging it across the front of the slide when we rotate it round, because if you remember, those 3 lenses twist. We're going to turn that fine focus adjustment knob to ensure that the image is nice and sharp and it focuses specifically on the cells that we want to be able to see. And then if we want to make that image larger with a greater magnification, we then switch to a higher objective lens, and we then use the fine adjustment knob only to sharpen that focus even further. Okay, when we're twisting that around, we do need to be careful that we're not damaging the lens onto the slide. Now, a couple of safety points. You need to be careful when you're handling glass slides, especially those little cover slips that go over the top, because they are very fine and will give you a nasty splinter. And you need to take care to not break that slide when moving it across the stage. Also, there is just that fundamental risk of electricity. Okay. So drawing cell structures, and today's activity is all about drawing cell structures, and I have attached a sheet where I would like you to send me your 2 images that you have drawn from photographs of what we can see down a microscope and label them. So a good biological drawing should be drawn in pencil, and the lines should be nice and firm and continuous with no gaps. And it's really important that these are not sketched or shaded. They should just be a plain line drawing. They need to be large and clear with the same proportions as the observed cells. This isn't a cartoon, but it isn't got to be a masterpiece of art. So we do need to make sure that they are nice and clear and they're proportional, okay? They need to be labelled using separate ruled lines, and these should be spread out with a bullet point on one end and a clearly written label on the other. And they're given a title that includes its magnification or size, and I'm going to go through how to calculate that in a minute. So this is an example of my onion cells drawn out, and this is my scale. So calculating the magnification of light microscopes. The total magnification of a microscope is the size of the object divided by the real size of the object. Now this is one of my favourite bits, the equation triangle, because you know how much from previous videos I love an equation triangle. So we can rearrange that, especially on the higher tier. You would be expected to rearrange that equation triangle to ensure that you can calculate what they're asking you to. Alright? So here's how to calculate it. And on this example, we can see we've got 25 micrometers, and it's really important that we understand that 25 micrometers is equal to 0.025 millimeters, and that conversion, if you don't remember that, can you write that down for me? So the skills being tested in this practical is whether or not you can use the light microscope, and you need to be able to describe how to set up the microscope, focus the slide, contain the specimen, and then make a labelled scientific drawing of what you see. So exactly as I said earlier, I'm giving you 2 electron micrographs, which are photos they've taken of cells down a microscope, and I'm going to ask you to draw and label those cells for me, and just snap a picture and send them in, and we're going to put the best ones on Instagram. It's always really good to see your work, and I just thought this is a bit more interesting than Sam learning. Take care, and I'll see you tomorrow.